Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR Hyderabad. Today I am going to explain about the Mason's gain formula, signal flow graph. In that we are going to use the Mason's gain formula. Now I am going to explain that. Just to move on to that outlines of today lecture. Just Mason's gain formula. What are the basic examples based on that Mason's gain formula? We are going to calculate the some problems. Means here we are going to calculate the transfer function by using Mason's gain formula. Just move on to here. What are the basic Mason's rules are available here? The block diagram reduction technique requires a successive application. Why we are going to study the signal flow graph? Means here by using the signal flow graph, and from that by using the Mason's gain formula we are going to calculate the transfer function easy compared to the block diagram reduction rules. See here, block diagram reduction technique, the Mason's or SJ Mason introduced some rules and give the some formula, that is the Mason's gain formula, in the year of 1953. Here the block diagram reduction technique requires successive application of fundamental relationships in order to arrive at the system transfer function. From the we are going to use, on the other hand, Mason's rule for the reducing the signal flow graph. Mason's rule for reducing the signal flow graph to single transfer function required the application of one formula only. Simply we are going to use the one formula for the calculation of the transfer function in signal flow graph, which is developed by the Mason, SJ Mason. So further here just below, the formula was derived by the SJ Mason when he related the signal flow graph to simulates the equations that can be written in the form of graphical representation or from the graph. The equations going to be made or else calculated, or we are going to written from the using the given graph or signal flow graph. Just here observe one exam. What is the Mason's gain formula here? The Mason, SJ Mason introduced his name. That formula is called as the Mason's gain formula. The Mason's gain formula is given by the T, or means here transfer function. Here transfer function T equals to transfer function is nothing but the output C of S divided by R of S, the output divided by input. Here summation in summation I equals to 1 to n number of summation, and P I delta I, or any variable you can choose here, Pk or delta k divided by the delta. Here see Pi, delta I and delta. Here C of S is nothing but the output and R of S is nothing but the input node. Here see C of S is not where the C of S is the output node and R of S is the input node, and T is the transfer function or gain between the R of S and the C of S. And also Pi is the ith forward path, where the Pi is the ith forward path. Pi is the forward path gain. And also delta equals to, here denominator in this here, delta equals to 1 minus sum of individual loop gains. Delta equals to 1 minus sum of individual loop gains plus sum of the gain products of all possible two non-touching loops. We know what is the mean by touching loops, non-touching loops and individual loops. We learned the basic definitions with the previous class, right? Here just observe 1 minus sum of all the individual loop gains we are going to add in this, and sum of gain product of all possible two non-touching loops of minus, here just simply we are going to remember just delta equals to 1 minus odd number. So odd number here, 1 minus is odd, next individual is nothing but the odd number, next positive, next even number may sum of two non-touching, next again minus, next 3 non-touching, next plus 4 non-touching, like that and so on. So easy to remember this one. Here delta I equals to 1 minus sum of all individual loop gains plus sum of gain products of all possible non-touching two non-touching loops, sum of gain products of all three non-touching loops, and so on. Delta I, here delta I is there, so delta I is there, this one. Delta I is obtained from the delta only, which is not touching to the ith forward path. Delta I is nothing but the which is to be not touching to the ith forward path. Delta I is obtained from delta by removing the loops which are touching the touching loops of ith forward path, or else which is not touching the ith forward path is value is directly considering, and eliminate the or removing the which loops are going to be touching the forward path or respected forward path. Any loops are touching that forward path. Now we are going to eliminate that forward path. Finally we get the delta I value, right? Here this is the very important formula, so easy to just remember. The transfer function is equals to summation I equals to 1 to n and pi delta I divided by delta. And next coming to here, one example I am going to here consider for the given given signal flow graph, we are going to calculate the transfer function. See here, transfer function given signal flow graph, just observe how many forward paths are available. Here see, y1 forward path means here input to the output node, the signal passing through the input node to output node. Here see, y1, y2, y3, y4, y5, y6, the signal is passing. This one is the one forward path, first forward path. And the first forward path gain, the gain product, the product of the gain is here. Just multiply the gain of this first branch, second branch, third, fourth, fifth branches, A, B, C, D, E. This is the gain. Second forward path, just observe. Y1 to Y2, Y2 to Y3 signal, Y3 to Y5, Y5 to Y6. This is the forward path, second forward path. The gain of that second forward path is equals to, just multiply this gain products, A, B and G, again here E. This one is the gain of this second forward path. Number of individual loops here. Now we are going to calculate the individual loops. How many individual loops? Here this one is the individual loop and this one is the individual loop or not? No, because of the signal Y3 is moving to the Y5 but not return back to the here Y4, Y3. So here moving to the Y6. So it is not a loop, it is a path, right? Here this is the self loop and here one more loop, and here from here to here this one is one more loop. How many loops are available? 1, 2 and 3. Next from here 4, and here see one more from here to here, and here and here to here. Complete this one. Y3, Y5, Y3 to Y5 to Y3. This is the one more loop. 1, 2, 3, 3, 4, 5. Total 5 loops are available here. Next here loops. Just next, this is the loop gains. Just gain of this BJ. This one loop 2. Loop 2 here. See, loop 2 gain is GH here. This is the gain. This is one more loop G and H gain. Loop 2 and loop 3. Loop 3 C here from here to here. This one. So C, D and H. C, D and H loop 3. Next loop 4. Loop 4 is this one. This one is the loop 4. D, I. Next here loop 5. Here loop 5 is here this one is the F self loop. Total the 5 loops. 1 loop, 2 loops, 3 loops, 4 loops, 5 loops. Total 5 loops are available. The loop gains respected. The loop gains are here. Just number of 2 non-touching loops. Here observe 2 non-touching loops. Just here observe 2 non-touching loops. This is the loop compared to this loop. These two are the non-touching. There is a no common node. So this is the one possible is there. So write this one. One first non-touching loop y2 to y3, y3 to y2, and y4, y5, y4. Here see y2, y3, y2, y4, y5, y4. So these two are the combination. Next here, gain product, that first non-touching loop is directly bj and di. bj di, just product bj di simply. Second non-touching loop, here see second first combination, second combination, this one is one loop, and compare with this one separately. This one loop and this one loop, both are different. So one more possible two non-touching loop combination is there. Just here observe y2 to y3, y3 to again 2, and y5 is the self loop. These two product of that value is just to multiply this. There is any more 3 non-touching, 4 non-touching, 5 non-touching loops are available? No. So here no more non-touching loops are available in the present given signal flow graph. So directly we know that formula is equal to delta equals to 1 minus sum of all possible individual loops. Just substitute here individual loop gains. Gain products are 2 non-touching loop gains here, and gain products of all possible 3 non-touching. There is a no 3 non-touching. This one is not suitable. Gain products of 2 non-touching. 2 non-touching is 2 loops are available, 2 combination. This one is the gain 1. This one is the and one more. These two just add here. And individual loops, total individual loops 5. 5 loops are just add here. 1 minus that value. Just see, observe delta equals to 1 minus first loop, second loop gain, third loop gain, fourth loop gain, fifth loop gain. Okay, all 5 individual loop gains. This is the 2 non-touching loops, first combination, second combination, third combination, 3 non-touching is 0. So finally we get the delta equals to this value. And here there is no loop is non-touching to the first forward path for calculation of the delta I. Delta I calculation means here I, how many forward paths here? Forward paths are 2 forward paths. So I equals to 2. So delta 1 we are going to calculate, and delta 2 we are going to calculate. Delta 1 is the first forward path which is not touching the loops of that first forward path. Just observe here. This is the first forward path. All the loops are going to be touching this first forward path. So eliminate all the loops. So directly 1 minus 0. So delta 1 equals to 1. Delta 1 equals to 1 only. And here delta 2, similarly we are going to calculate the delta 2. No loop which is not touching the second loop also. Just observe second loop. This is first forward path, second forward path from here to here. So y1 to y6 passing through the g value, g gain g, and here there is no non-touching loop. So again delta 2 also 1. Delta 2 also 1 minus 0 is nothing but 1 only. So delta 1, delta 2 we know. Substitute the value here, delta 1 n equals to 2 here, I1 to 2. So expand this term, P1 delta 1 plus P2 delta 2 divided by the delta, and here substitute the P1 value, first forward path, into delta 1. Delta 1 equals to 1. P2 forward path gain, second forward path gain, delta 2 1. Again substitute 1 minus individual loops, all the individual loop gains plus 2 non-touching loops. Finally we get this answer. This is the transfer function of the signal flow graph from the given signal flow graph by using the Mason's gain formula. It is easy compared to the previous block diagram reduction rules. We have a lot of rules we are going to use that is difficult compared to the signal flow graph by using the Mason's gain formula. Just we remember the first Mason's gain formula. From that we are going to calculate the what are the loops, individual loops, any 2 touching, 3 non-touching loops are available, any forward paths touching loops are available or not. Just we are going to add all the products into that formula. Finally we get the transfer function. It is easy compared to the previous block diagram reduction rules. So this is about the signal flow graph, and this finally transfer function is this one by using the Mason's gain formula. So this is about the signal flow graph, the basic elements, and one best example to calculate the transfer function by using the Mason's gain formula. Thank you all.